Okay, in this module we're going to just do an example of convolution with a delta function. So if you recall from the previous module, the part 1, convolution part 1, a very useful fact was the fact that if you take g of x and convolve it with a shifted Dirac delta function, then your output is simply a shifted version of your original input. So for example, if I had g of x as maybe some function like that, and I convolve it with a Dirac, let's say this is at 3, so this is delta of x minus 3, then my output is simply a shifted version of g sub x. So it would be, here's 3, and then this is the g of x minus 3. All right, so that's a very useful fact to keep in mind because convolving functions with Dirac delta functions is actually a very useful operation for a lot of medical imaging problems. Let's now do a short example. In this case, I have a rect function convolved with a delta located at 3/4 or minus 3/4, and so we need a plus here, plus a delta located at minus at 1/4, so we have x minus 1/4. And then we would just apply that property, then we have the answer is simply x, rect of x plus 3/4 plus rect of x minus 1/4. So this is just a rect function shifted to be centered around minus 3/4, and another rect function shifted to be centered around 1/4. I can also think about this graphically. So let's draw our rect function, minus 1/2 to 1/2. And we're convolving this like this. Okay. So we want to think about what would happen if I took my rect function and I centered it around the first delta function. So remember with the rect function we go 1/2 one way and 1/2 the other way. So we're going to go all the way here to minus 5/4, then all the way here to minus 1/4. And so that shifted function is just simply rect of x plus 3/4. All right? And then we also have to convolve with this one here. So that's centered around 1/4. So I have this delta function here. Okay. So if we think about going 1/2 to the left, it's here, and 1/2 to the right, it's here. Okay. And so that shifted rect function is simply rect of x minus 1/4. And so our answer is just this rect plus this rect, which is exactly what we got up above.